This is the second part of the video on anti-malarial drugs. In this video, I'm going to explain about the classifications of anti-malarial drugs and some of their modes of action. You can see in this slide the classifications of anti-malarial drugs are your 4-aminoquinolines, 8-aminoquinoline, cinchona alkaloids, quinoline methanols, biquinolines, diaminopyrimidines, your sulfonamide, tetracycline, eptoquinones, sequiterpene lactones. I'm going to explain you the mode of actions of some of this example. Let's see about the chloroquine. What do you understand by chloroquine? And this drug, it was first synthesized in Germany, and it is become the cornerstones of anti-malaria chemotherapy for the next 40 years. It quickly became the drug of choice globally to treat uncomplicated Plasmodium falciparum infection, and it was used as part of the global malaria eradication campaign launched by the WHO in 1955. As you can see, it is one of the least expensive anti-malaria available, and it is still in widespread use. This drug, it can be taken both as a prophylactic and as a treatment. This drug inhibits DNA and RNA biosynthesis and induces the rapid ribosome RNA. The inhibitions of a protein synthesis is also observed evidently as a secondary effect. It has been generally antimicrobial mechanism of actions of the chloroquine. Chloroquine accumulates in a very high concentration in the parasite food. Once in the food vehicle, chloroquine is thought to inhibit the deoxydifications of heme. Let's see the mechanism of actions of these drugs. The mechanism of actions of chloroquine, it says that it inhibits the DNA replications. This is the general antimicrobial mechanism of actions of these drugs. As it's thought to be inhibit the oxidifications of heme, chloroquine become protonated because the digestive vehicle is acidic, that is pH 4.7, and subsequently cannot leave the vacuoles by diffusion. This chloroquine cap hemozoin molecules and prevent the further biocrystallization of heme. Thus, they lead to the heme buildup. Now this chloroquine, it binds to the heme, or you can say as FP, to form what is known as the FP chloroquine complex. This complex is highly toxic to the cell and disrupt the membrane function. The actions of toxic FP chloroquine complex and FP result in cell lysis and ultimately the autodigestion of the parasite cells. In essence, the parasite cell drawn in its own metabolism product. And about the quinine. Quinine is derived from the bark of cinchona trees, as you already studied in pharmacognosy, and it is used as the treatment for the uncomplicated and severe malaria in many different therapeutic regimens. This quinomax, which is combination of quinine, quinidine, and cinchona, is also used for the administration for only 7 days to non-immune populations. Mode of action of quinine act in a manner which is similar to that of the chloroquine, but with some differences. Like chloroquine causes clumping of the malaria pigment, whereas this quinine it antagonizes this process. In addition, this quinine is a weaker base than as we compare to the chloroquine and has less affinity for heme, implying that mechanism other than ion transport into the food vehicles and heme-drug interaction are required for the actions of these drugs. Quinine also interact rather weakly with heme. Little bit about the mechanism of action of mefloquine and halofentrin. Since you have already known that this mefloquine is a tricyclic compound that was developed at approximately the same time as was with the mefloquine, and they are been used as a second-line agent, and its use may be limited by its cardiotoxic side effect and variable pharmacokinetic. Their mode of action is that mefloquine interacted relatively weakly with free hemp, which report the KD value ranging from 3.3 into 10 to the power 7 to 1.63 into 10 to the power minus 5 m. Now, it has been shown to inhibit the hemp polymerization in vitro with a similar or lower efficacies than that of the chloroquine. Given the lower basicity of mefloquine, it seems unlikely that it will reach the intravascular concentration required to inhibit the hemp polymerization. Last is about the antifolate mechanism of action, as this is some of the most widely used anti-malaria drugs which belong to the folate antagonist class. They have been classified into two types, that is type 1 antifolate. You will find that drugs it is sulfonamide and sulfon, and number 2 is type 2 antifolate, that is your drugs is namely pyrimethamine, biquinines and triazine. So their mode of actions is that it inhibit either dihydrofolate reductase, that is you can call in short as the DHFR, and the drug which inhibit this is pyrimethamine and cycloquinine or dihydropyridate synthase, that is your drug will be your sulfadoxine. These are the two key enzymes in de novo folate biosynthesis which inhibits this metabolism pair will lead to the inhibitions of biosynthesis of pyrimidine, spirine, and some amino acid. This antifolate anti-malaria drug interfere with folate metabolism, a pathway essential to malaria parasite survival.